Good morning, everyone. Today we'll see about some few basic concepts in physics that is very much useful in solving basic fundamental questions in it even. So, so the main motive of this video to solve a mediatory level question in NEET. So we will see what the question is in the end of the video. First, we will understand what is physics. The first slide itself says that the definition or the meaning of physics. Physics is nothing but the study of behavior of nature. We can precisely say as the behavior of nature. So, in nature, if you look at nature, there will be something in common among all. What that is something must be in moving or else at rest. So if you take if you look at outside, the thing you will note is the tree will be at rest, or some bird will be in moving, or some lakes is at rest. When you look at overall, under the water in the lake will be moving. So that was the common thing. So this the physics is all about the motion and rest, study of motion and rest. So even if you look at the chapters in NEET syllabus or else in higher secondary syllabus, you'll find that the first lessons, the first few lessons will give a basic idea about what is motion and rest, and further chapters will define what are the types of motions. For example, if you take a rotatory motion, it says that the object will be rotating. The kind of motion is rotation, and the oscillatory motion, it will be periodic. So that is a type of motion which involves, and another type of motion in nature is vibration. Even vibration comes under oscillatory motion. So in these are the types of motions. So when you take the 12th chapters, it will clearly describe that the motion with respect to particles, the behavior of different objects according to motion. For example, if you take the first chapter of 12th standard, that is electrostatics. So a charge at rest. So a charge has some capacity, some particular behavior when it is kept at rest. So we will study those things in electrostatics. When it is the charge is in motion, we will see about that in current, flow of electric current. And when the charge is in motion, another important character will be significantly noticed. That is the magnetic behavior of the charge. So there are many. So we will study about that, and not only these things. If you consider motion, we will observe many kinds of motions. So if you took in if you take it into an atomic level, the electrons are also revolving around the nucleus, and the neutrons also are in some kind of motion. So we will study about those things in quantum or somewhat lower level physics. Then in atmosphere level, we will study about solar systems. So everything in motion or rest. So in 12th standard, the last portion of 12th standard will be given to study about semiconductors. The semiconductors, the behavior of material according to the motion of electrons. So if you look everything, the study of physics is about the study about the motion and rest itself. So, so what is a rest? Secondly, we will define what is a rest and motion. So rest is nothing but so if you define rest in a naive way, we will look at objects. It remains at same position for long time. We define rest as does not change its position with respect to time. So that what we mean is a rest. So if you look at those two graphs, the first graph clearly shows that object is in motion. So if you look at time and the distance is changes with respect to time. That what that curve is noticeable like that. Okay, when you look at the second graph, the line is the straight line denotes that the object is at same position at the same 100 meter. Second graph 100 meter throughout the time, even at the first second throughout up to 50 second, it is at the same position 100. So it is at rest. We can clearly define that the object is at rest. Okay, so for example, the book on the table is at rest. We can say the book, if you keep a book on the table, it will remain at rest for a long period. So the house you are living is at rest. Okay, so what is difficult about that? Rest is very easy, right? So okay, we will go into the main part of the rest under motion definition. So if you go to moon from earth, okay, it's possible nowadays. When you go to moon and you see those two objects, which is the book on the table and the book on the table and the house you are living, okay, you see these two objects from the moon. It's possible through some good instruments nowadays. So when you look at those, you will shock that these objects are moving. When you look those objects from moon, right, because the earth is revolving, the earth is in motion. So when you look those objects from earth, it is at rest. When you go to moon, it is at motion. So what's problem in this? Can you just guess what's the answer is? So now look at it, another example. Now consider a train is moving. Okay. Now okay. Now you there are two situations is given. You are the observer and you are traveling in the train. Okay. So first case is you are in the platform and looking at the train moving very fast. Okay, so what will you state? That the train is moving, you will state that the train is in motion. So when you are inside the train, you will state that see second image, that he's coolly listening to music as nothing is happening. So he doesn't feel that the train is moving, so he feels that the train is at rest. So so what is more significant here is, so there is no absolute rest or motion. It all depends on observer. When the observer is at rest, and the objects will be in motion. Okay, so likewise happen many cases. Okay, so what we have to define is the frame of reference, the new term, the frame of reference. What we will mean by frame of reference is, reference, we have to refer something to an object in motion or rest. Okay, so when you look at moon, you'll clearly say that the moon is at rest for a long time, because you don't know that the space is very common all along all way. So you could not find the moon is moving or not. After some 2 to 3 hours, you'll find that yes, moon has changed its position. Then only you will define yes, moon has changed its position. So what is needed is a frame of reference to define the position of an object. So frame of reference can be anything, like anything which is stable in a position. Okay, so we will look at a frame of reference in a further good video, because it needs some kind of deep understanding. So in mathematically speaking, we can define a frame of reference in a Cartesian. There are many frame of reference. We can simply take a Cartesian frame of reference as a basic frame of reference. It has some three axes, x, y and z. It is almost needed, it is enough to specify a point in a or an object in a space. Okay, because the space is three-dimensional and the Cartesian coordinate also three-dimensional. So now we will go into some good concepts. So first we will define what is distance and displacement. We all familiar with the words distance and displacement. Okay, so what is distance? So if you look at these two see if you look at this image, you can find the two paths. So we know that physics is nothing but study of motion and rest. So I'll say here an object is moving, okay, along two paths from A to B, okay. First path is very curvy, you can find that is distance, and second path is displacement. Displacement by the meaning you can understand that displacing something, okay, from point A to point B, displace, okay, that's what. So I missed the slide. Okay, so distance is a okay, I'll search for the slide. Okay, distance is path taken by an object. Displacement is shortest path taken by an object. Okay, whatever path, if you given so many paths to travel, the shortest path you take is called is known as the displacement, and remaining all the path is distance. So if we give so many examples, we can understand better. So physics is about imagination. You need more examples and more imagination to understand a simple concept. It is very simple when you imagine. Okay, so now we say about speed and velocity. Speed is nothing but distance by time taken. What you mean by distance by time taken? The change of distance, the change of position with respect to time is speed. Okay, when someone say you're traveling 30 meter per second, 30 meter per second, okay, you traveling 30 meter per second. So after 2 seconds you will travel 60 seconds. After 3 seconds you will travel 90 meters. Okay, that what it is. Speed is distance by time taken. We will define speed as this. Okay, velocity is displacement time by time taken. We have to define another two terms here. What is scalar and vector quantity. So we will need a further video for defining these things. So for now, simply we will take velocity as a vector quantity. It needs direction to define the velocity. So speed don't need direction, and velocities must specify with the direction. If you given a question about a speed, you don't need direction to answer it. But when velocity is given, you need direction to answer the question. Okay. Now we'll come to acceleration. Acceleration is nothing but velocity by time taken. So velocity is equal to displacement time taken, and acceleration is velocity by time taken. You know now that velocity is equal to displacement by time taken, so acceleration will be displacement by time taken square. It's some mathematical logics, that's it, nothing more here. So when physically we define acceleration, we can understand that when you move in bike, someone will say don't accelerate, just go in a constant speed. So what does that mean? Acceleration is increasing the speed, increasing the speed from so when you start, you will just start with a 0 meter per second square. So if you accelerate, the speed will change with respect to time. So if you want to increase the speed, you must accelerate. That what physically acceleration is. So now we will see a moderate level neat question. Okay, the variation of velocity of a particle with time moving along a straight line is illustrated in the figure. The distance traveled by the particle in 4 seconds is 60 meter, 55 meter, 25 meter and 30 meter. So this what his question is. What is important here is in physics you have to understand the key terms in the question itself. So here the variation of velocity of a particle, the physical terms are velocity, okay, one, and the variation of velocity with the time. What is variation of velocity with the time? You know that by definition of acceleration is equal to velocity by time taken, right? So the variation of velocity of a particle with time is nothing but the acceleration. So the graph here denotes the acceleration, okay, moving along a straight line. So when I said that velocity must be defined with the direction, So here also same thing happened. They defined velocity and they said that moving along a straight line, they also denoted the direction. Okay, so along a straight line is illustrated in the figure above. The next physical term is the distance traveled by the particle in 4 seconds. They asked the distance. Okay, okay. Now we'll solve this question. We'll we'll cut short this question and we'll solve this step by step. So first step. So okay, these are the main hints we have to note from the question. Variation of velocity with time, moving along a straight line, and we have to find the distance traveled in 4 seconds. So first the graph, if you take the graph, they'll plot x-axis along time along x-axis and velocity along y-axis, and they are in meter and it is in second, time is in second. Okay, so this is what the graph is. So if you look at the graph, this is acceleration graph, velocity and time is given. So the line denotes the velocity. Okay, velocity from 0 to 20, then 20 meter constant, then it decreases, then along and suddenly down to 0. Okay, so if you this figure can be imagined with a bike. Okay, a bike starts at rest and accelerates up to 20 km. See, it accelerates straight line along a upward direction and keep constant for 20 meter for 1 second. So between 2 to 3 seconds it keeps constant 20 meter per second, and then for 1 second it decreases to 10 meter per second for next second. Okay, then again constant velocity and suddenly applied brake. Okay, and came to 0. This what is the question. Okay, this needs many conceptual understanding and needs a good time of practice so that you can understand it better. Don't worry if you didn't understand, because it needs a little understanding, little time it should take to understand the concept. So you know that distance can be distance is equal to speed into time, you know that, right? Distance is equal to speed into time. So when the mathematical concepts of integration is involved, I guess that you are well aware of the concepts of integration and differentiation, and also know that integration of velocity into time gives the distance. That's that you need more understanding of the concepts. I'll just not force you to understand those things now. Okay, so I'll just note that x is equal to integration of velocity and time. So when you to look at the diagram, there will be four paths. Okay, there will be four paths. See, first part is a right angle to triangle, second part is rectangle, third part is rectangle and right angle triangle, and fourth part is just a rectangle. So you know that when you have to integrate means we have to find the area. If you are good at integration and the concepts, you will know that integration is nothing but finding the area. So you have to find the area of this, right, these four figures, and you know the formula too. Right angle triangle, half into b into h, rectangle l into b. That's what. Okay, when you apply those things, half into b into h, b is nothing but breadth, that is 1 second and 20 meter, and those things if you substitute you'll get answer as 55 meter per second. So okay, this what I just urged you, because there are many concepts need to be understand to understand the whole question and video. So we will look slowly the few concepts and practice more questions to get this question right. And don't worry if you could not solve this question at the first instant. Thank you.